When you're dealing with the vastness of space, distances can be measured in how long it takes light to travel. We visited the Wellesley College Observatory and spoke with Kim McLeod, who studies some of the most distant objects that we know about in the universe, objects that are light years away.
My name is Kim McLeod, and I'm an assistant professor here at Wellesley College in astronomy. For astronomers, it does make a big difference that light travels at a finite speed, because here on Earth, on the cosmic scale of things, the Earth is pretty small, and it doesn't take light much time to travel these distances. It looks nearly instantaneous to us. But on the scale of space, distances are very big, and so even light, which travels as fast as anything can travel, even light takes a long time to traverse these distances in space. Just to give you an example, for light to travel from the sun to us would be a little over 8 minutes. Moving out in the solar system to Saturn, it would take light an entire hour to travel from Saturn to us. So as you can see, the big distances of space mean it takes light a long time to travel them. If you want to go beyond the solar system, then it's going to be convenient if we talk about something called a light year first. If light can travel from here to Saturn in an hour, how far does light travel in 1 year? And the answer turns out to be about 10 trillion kilometers. And this distance, 10 trillion kilometers, we call a light year. Things beyond the solar system are far enough away that we like to tell about their distances in light years. So, for example, the nearest star to our own sun, the Proxima Centauri star, is a little over 4 light years away. That's its distance, means light's taking more than 4 years to get from it to us. Maybe you want to move a little bit further out towards the realm where I work in my research. We could talk about galaxies, like the Andromeda galaxy, which is the nearest big galaxy to our own. It's so distant that it takes light 2 million years to get from it to us. Now, this has some interesting implications for astronomy, because remember, I just said it takes like 2 million years to get from Andromeda to us. That means when I see the Andromeda galaxy through my telescope tonight, I'm actually seeing what it looked like 2 million years ago. So the finite speed of light lets us be sort of cosmic archaeologists. It lets us see what galaxies look like millions of years ago. Let's say you have a friend who's traveling through Europe and has just visited the Leaning Tower of Pisa and writes you a postcard. It says, today's Monday, and we went to the Leaning Tower of Pisa, and we had pizza, and pizza here tastes different than pizza there. And then the postcard is mailed to you. And it doesn't get there for maybe a week, maybe 10 days. And when you get the postcard says, today is Monday, we're at the tower, but your friend is not there. This represents a snapshot in time from last week. Same thing with the light from the Andromeda galaxy. So what I study is quasars, and these are very powerful galaxies, and they are so distant that it's taken the light about 10 billion years to get from them to us. So by studying these quasars, I can learn about what the universe looked like, what galaxies looked like 10 billion years ago.